So now I want to do is find, we know that the balloon is inflated at a constant rate. So right away I know it's cubic, so the rate that it's inflated is 44 cubic millimeters per second. Find the volume after so many seconds. A volume is a cubic millimeter, so volume is going to be 44 cubic millimeters per second. And if I want to get rid of the time, I'm going to multiply it by time seconds, and that's now my new function, 44t millimeters cubed. When the volume is v, what is the radius? Well, the volume of a sphere is 4/3 pi r cubed. We need to solve for r. So what I'm going to do is I'm going to multiply this by 3/4 pi and 3/4 pi. So now what I get is 3v/4 pi equals r cubed. So r is going to be the cube root of 3v/4 pi. And if I'm cubing a millimeter cubed, then this is going to be a millimeter. So that's the answer for part B. Write an equation that gives the radius as a function of the time. In other words, not a function of the volume, but a function of the time. And then find that radius after 5 seconds. So r equals the cube root, 3, and v happens to be 44t all over 4 pi. So what I'm going to do is simplify this. I am then going to put the time of 5 in here. And then what I'm going to do is simplify this, plug it into my calculator, and get 3.74 millimeters. That's the radius after 5 seconds. Now, we did this in the first handout. Any set of ordered pairs in the form of x, y is a relation, but not all relations are functions. So this is example 6. We're going to look at these ordered pairs, and we want to know if it's defined by this function. And all that means is I take the x and the y and I substitute it in. So I've got squares, and I have squares equals 5, and I put 2, -5, and -5. 4 times -5 is -20 plus 25, and lo and behold, this definitely is a solution to it. I'm going to do the same thing with the 1 and the 3. One times 3 is 3 plus 9 equals 5. 12 does not equal 5. So this one is not a part of the function, or of the relation. Do the same thing with the next one. 2 squared times 1 plus 1 squared. Now I get 4 plus 1 equals 5. And this one definitely is a part of this relation. Now I got to determine, is this relation a function? Well, 2 goes to -5 and 2 goes to 1, so no, it is not. Sometimes a relation may not be a function, but if you solve for y, you will find that the relation defines multiple functions. This one is very difficult to put into your calculator, so we're going to factor this. X and x, y and y. I've got it factored. So now what I'm going to do is rewrite it, and we want to solve for y, so we square root both sides. So now I have x plus y equals plus or minus 1. So y is going to be minus x plus or minus 1. Now if I graph that, that's y equals minus x plus 1 and y equals minus x minus 1. Well, let's see. That means one graph goes this way, the other one goes here. They go through the point +1 and -1, and you now have parallel lines. And obviously, this is not a function. It does not pass the vertical line test, so not a function. Now defining parametric equations. This is our parametric equation, and we are going to look for finding these points. So if I have t, and I have x, and I have y, I'm going to plug in these values into my equation. So what I'm going to do is I'm going to take negative 3 plus 1, that's a negative 2. Negative 3 squared is 9, plus 2 times negative 3 is going to be 3. And I'm going to put every single one of those points in. So I'm going to put negative 2 plus 1. I'm going to put negative 1 plus 1. I'm going to put 0 plus 1, 1 plus 1, 2 plus 1, and 3 plus 1. Then I'm going to take the same t value and put it into here. Negative 2 squared is 4, minus 4 is 0. Negative 1 squared is 1, minus 2 is minus 1. Then I'm going to put 0 in here and I get 0. I'm going to put 1 in here and I'm going to get 1 plus 2, which is 3. 4 plus 4, which is 8. 9 plus 6, which is 15. So now I have found all my points. It's going to be negative 2, 3, negative 1, 0, 0, negative 1, 1, 0, 2, 3, 3, 8, and 4, 15. Now part B says find a relation where it's just x and y. Well, that means I need to get rid of the t. So I'm going to take x equals t plus 1. I'm going to solve for t, and then I'm going to substitute what t equals in here, and then I'm going to simplify x squared minus 2x plus 1 plus 2x minus 2, and now I actually have my relation. It looks like a parabola. Well, if I just graph these particular points, and all I'm going to do is graph these particular points, I'm going to take my graph, I'm going to graph negative 2, 1, 2, 3, negative 1, 0, 0, negative 1, 1, 0, 2, 3, 3, 4, 5, 6, 7, 8, and then 4 and 15. So this graph kind of does something like that. Now, what happens if we want to put these in our calculator? This is the equation that we have. And we're going to see if our calculator will do it for us. All right, here's example 9. Use the graphing calculator. So here's my equation, and the first thing I'm going to do is I'm going to put it in the correct mode. So let's see if you can. I'm going to turn this on. I'm going to clear my graph, and I need to be in parametric mode. What does that mean? Now, let's see if you can see. Now what we're going to do is we got to put this in parametric mode. So let's go to mode. Now do you see function parametric? So I have to scroll down, move over to the right one, hit enter. Now when I go to the y equals, notice I see x and y with t's. So I need to put in this equation. So let's see what we have for this equation. What I'm going to do is I'm going to put in t. Now I press where the x button was and I get a t now. T squared plus 2t. Then I'm going to go down 1 to the y and I'm going to put t plus 1. Now what I'm going to do is I'm going to go to my window. Now according to this, I only want from negative 3 to 3. So I'm going to put negative 3, and I'm going to put to 3, and my t-step is in integers. I'm going to go up by ones. Now what I want to do with my window is I'm going to put this in a normal window. I don't want to have to sit here and try and figure out where that goes. So I'm going to put this in a normal window with a scale of 1. Let's see how this looks. The first thing they wanted us to do was to graph or to find the points. Alright? A couple ways you could do this. I could go to the table and notice when t is negative 2, my point is 0, negative 1. When t is negative 3, my point is 3, 2. So I could list every single one of those down. And I'll do that. So it says, using a graphing calculator, find the points. Well, we found them. There they are. Now it says graph it. So what I'm going to do is I'm going to hit graph. When I do that, notice I've got kind of a sideways parabola. And then the part C says, is this a function? No, I can't. I don't pass the vertical line test. And then I need to find an algebraic relation, which just means get rid of the t. So for part A, this is what I'm going to write. For part A, I'm looking at the points. So let's go back to the table. I can do 3, -2. The next point is 0, -1, -1, 0. The next point is 1, 0, 1. The next point is 3, 2, 8, 3, and 15, 4. So those are my points. Part B says to graph it. Well, when I graphed it, this is what it looks like. So when I show my graph, it's going to go kind of like that. Part C says, is it a function? No. And part D says, find an algebraic relation. Alright, so to show you how I'm going to do that, I'm going to take this piece of paper and I'm going to take x equals t squared plus 2t, y equals t plus 1, and I need to solve for t. Well, I don't want to square root anything, so I'm going to say y minus 1 equals t. And now I'm going to substitute it into here. Now when I do that, I can expand this, multiply it through, add like terms, those go away, minus 1. That's now my algebraic relationship between x and y.